Hello, classmates. Starting from this lesson, we will study the relevant knowledge of three-phase sinusoidal alternating current circuit. Electricity, commonly used in household electrical equipment, is sinusoidal alternating current. It is also one phase of three-phase alternating current. So in this chapter, we will study related knowledge of three-phase sinusoidal alternating current. In this lesson, we will study generation of three-phase power supply. What is a three-phase AC circuit? How to produce three-phase AC power supply? Let's embark on today's study with these questions in mind. At present, in power engineering, three-phase power supply is widely adopted. A three-phase AC circuit consists of three amplitudes that are equal in magnitude, with the same frequency, and are out of phase with each other by 120 degrees. It differs from single-phase power supply, which is composed of a circuit with single-phase AC electromotive force. What are the advantages of this three-phase power supply compared to single-phase power supply? Its advantages are embodied in the following three aspects. In terms of power generation, a three-phase alternator has higher capacity compared to a single-phase alternator of the same size. In terms of power transmission, if the same amount of power is transported to the same distance with the same voltage, a three-phase transmission line requires less material than a single-phase power line. In terms of electrical equipment, a three-phase AC motor has advantages, such as simple structure, small volume, and good operation characteristics compared to a single-phase motor. Therefore, the three-phase system is currently the main power supply method used in countries around the world. Three-phase sinusoidal alternating current circuit has many uses. Most of the electrical equipment in the industry rely on three-phase alternating current, such as motor generators, etc. In China, three-phase alternating current is extensively used in power production and transmission. Now, let's take a closer look at how the three-phase sinusoidal alternating current is generated. It all starts with the generation of a symmetrical three-phase power supply. Three-phase AC electromotive force is generated by a three-phase alternator. Figure 4.1.1 illustrates the schematic diagram of a three-phase alternator. The power supply that provides the three-phase electromotive force is referred to as a three-phase power supply. If the amplitudes are equal, the angular frequencies are the same, and the initial phases differ by 120 degrees, then this three-phase power supply is called a symmetrical three-phase power supply. So how do we express the symmetrical three-phase alternating current? Generally, three-phase power supply is called U phase, V phase, and W phase, or phase A, phase B, and phase C. When taking the U phase as the reference for symmetry, the expression of three-phase power supply is EU equals EM sine omega t, EV equals Em sine of omega t minus 120 degrees. EW equals Em sine of omega t plus 120 degrees. The symmetric three-phase power supply can be expressed using phasors. The U-phase electromotive force phasor is equal to the amplitude E with a phase shift of 0. The V-phase electromotive force phasor is equal to the amplitude E with a phase shift of minus 120 degrees. Lastly, the W-phase electromotive force phasor is equal to the amplitude E with a positive 120-degree phase shift. Waveform diagram of symmetric three-phase alternating current and phasor diagram are shown in Figure 4.1.2. Is there a sequence of three-phasor alternating current? The term used to describe the sequence of three-phasor alternating current is called phase sequence. What is phase sequence? The order in which the three-phase alternating current reaches its maximum values is called phase sequence, as shown in Figure 4.1.1. Phase sequence of alternating current refers to the order in which the positive maximum values are reached as U to V to W to U, or A to B to C to. This sequence is known as the forward sequence. Conversely, the order of reaching the negative maximum values is U to W to V to U, or A to C to B to A, referred to as the reverse sequence, unless otherwise specified. The phase sequence of a three-phase power supply is always in the forward sequence. Symmetric three-phase alternating current possesses certain characteristics. Let's analyze them. Due to the characteristic that amplitude and frequency of each phase electromotive force in symmetrical electromotive force are equal, and the phase difference between them is also equal, the sum of the instantaneous values, or vector sum of the symmetrical electromotive force is 0, namely EU plus EV plus EW equal 0. The sum of the instantaneous values or vector sum of phase U, phase V, and phase W electromotive force all equal to 0. How is AC externally connected to the load? And what are the connection modes of three-phase power supply? Three-phase winding of three-phase generator is not usually provided with power separately, but it is connected in a certain way to join together and simultaneously supply power to the external load. The basic connection modes of the three-phase power supply include star-Y connection and delta connection. How to distinguish the two specific connection methods we will study in depth next class. The main focus of this lesson is on learning the advantages of three-phase electricity, the process of generating three-phase alternating current that meets certain requirements, the representation of symmetric three-phase alternating current, the representation of symmetric three-phase alternating current load. Classmates, see you next class.